Good morning, everybody. Welcome to Atlanta, Georgia for our 2023 Community Exchange. It's really great to see so many of you here today and get back to getting people together in the real 3D world, and I'm really looking forward, hope you are too, to a great week. There are so many folks that worked really hard to get us back to this point, and I'd first like to recognize our amazing Community Exchange Program Committee and their hard work and dedication for helping us to put this terrific program together this week. I hope you'll take advantage of all the great content and sessions, as well as time to talk to each other without having to remember if you've hit mute or not, and all those connections to build and create a collaborative and inclusive and a welcoming community. So much has changed over the last 4 years. Our community has been through a lot and has continued to evolve. We have been through so many times together, but the community is resilient and will continue to thrive as things continue to change. Normally, we would be sharing information about our new members over the year, but today we want to recognize how our community has changed over the last 4 years. And so please join me in welcoming our new higher education members, our new affiliate members, our new regional and state network members, and our new industry members. So speaking of our industry members, I'd like to recognize and extend our extreme thanks to our generous sponsors for this event. So I want to thank our platinum sponsors, Cisco and Juniper, gold and silver level sponsors. And we're very grateful for your generous support, which plays a large part in holding such events and convening the community. And so at this time, please let me invite to our stage our first platinum sponsor representative, Mike Shepard from Cisco. Mike.
He stole my lines about 3D and off mute, so I got nothing. So I just want to say, listen, wow, those are bright. You have shades for me, Taylor? I just want to say good morning for those that I don't know or that don't know me. I don't know a lot of you. I'm Mike Shepard from Cisco. I'm a business development manager in our public sector organization. And I've been coming to these events for maybe 6, 7 years now. There's this funny story as I snuck into the first one, and I'll tell you about that over a cocktail many, many years ago. But before I get into a couple key items, I want to thank Carl and Shannon for the workshop that they put on yesterday around automation and orchestration. That's a very big deal. And Carl, I can't see if you're out there, but thank you, and Shannon. That means a lot to us. I also want to thank, I guess it sounds like an acceptance speech. I want to thank Nick and Sean and Kevin and the Net Plus team. The Duo business, an acquisition we made a few years ago, is a very big deal. It is a guiding light to our relationship. We want to do more of that, and we really appreciate that support, and we hope that continues well into the future. Howard stole my line. I want to thank Taylor and the whole team for organizing this event, because it makes it so easy for us to show up and participate, and again, you do a wonderful job, and thank you for that. And lastly, I want to thank Internet 2 for the partnership that they provide us. We love it. We're invested, and we hope that it continues for years to come. And just a few more comments. As I look out over the next 12 months, what I'd like to do is be standing here again and talk about the success we've had in automation and orchestration. Cisco's network service orchestration is being adopted across the community the workshop that we saw yesterday, the Slack channel. We think it's a very big deal, and we're here to help the community embrace it. We really want to make sure that the community gets value. So that, I think, is a key initiative for the next 12 months. In that same vein, our Thousand Eyes acquisition. I do have t-shirts, I'm told, at the FedEx building if you want to stop by our suite. There's been some movement and some discussions and the adoption of that offering. We hope to add that to our community discount program. Those are air quotes. And ultimately, I'd like to see it on the Net Plus program. That would be a goal that I'll set for the next 12 months. Another big deal for us in the coming year is private 5G, CBRS, private LTE, whatever you want to call it. Universities are embracing it. I know Howard's got a working group. It's very, very important to us as we look out of the future of networking and how that'll evolve to meet the community's needs. And lastly, and I hope I don't jinx this, we're working very closely with the Global NOC on a connected lab. There's been some interest from a few universities that said it would be great if there was somewhere that was on net that we could test to. That is a work in progress, and I hope to close that in the very near future. I said it at the onset, thank you, Internet 2, for the partnership, and I hope everybody enjoys the show. Thank you.
Thanks, Mike. And we saw you sneak in, so you didn't get away with anything. So I was trying to remember the last time I gave opening remarks, and it was 2019. And I actually went and found my note. It was probably stuck in my sports coat. And we had just marked the 20th anniversary of the Albaline Network and the launch of the Community Middleware Initiative. And we were just forming our next generation infrastructure network program team and had announced that Cloud Connect was a production service. The 3-year tier program had come to an end, and we were moving the future development under the InCommon umbrella as part of a new family of solutions called the InCommon Trusted Access Platform. And we had reached a great milestone of 90% compliance across the community in the InCommon Baseline Expectations version 1. So here we are today, the NGI program completed, giving us our 5th generation national network capable of delivering 400 gigabit per second services to meet the needs of the community, whether that's for data intensive science, distance learning, remote work, cloud access, and global collaborations. As Mike mentioned, automation is a pillar of the NGI program, and we have clearly heard from the community they want to add more intelligence to the network. So we've just also released our first version of Insight Council, which is our web-based council allowing members to visualize, manage, and troubleshoot services on the network, and that's going to be a key focus for us going forward. And of course, NGI would not have been possible without the tremendous effort of all the community participants who helped, and especially our colleagues at the Indiana Global NOC, who are great, continue to be great partners. Security is top of mind for all of us, and routing security specifically is gaining a lot of attention. In 2022, the FCC issued a notice of inquiry about internet routing vulnerabilities. In March of this year, the Biden-Harris administration announced a national cybersecurity strategy that referred to routing vulnerabilities as an urgent and pervasive concern. So Internet 2's routing security program is focused on working across the ARNI community to improve routing security for the entire ecosystem. Our trust and identity portfolio has made some significant progress over this time as well. The InCommon Federation is higher quality and more trustworthy and more secure. And in January of 2023, we've now gotten to 98% of InCommon registered entities meeting the baseline expectation version 2, which is a fantastic milestone. And the Trusted Access Platform has also demonstrated its ability to take on new capabilities. For example, In the last year, over 100 features have been added to Grouper. And Eduroam, everybody's favorite service, continues its rapid expansion in the US. We've made some massive, significant changes to the underlying infrastructure to provide scalability. And it's beginning to take root in K through 12 through our Eduroam support organization program and our regional network partners, Connected Nebraska, Connecticut Education Network, Link Oregon, Sun Corridor Networks in Arizona, and the Utah Education and Telehealth Network have really helped and been great partners in getting up to now over 1,000 subscribers at the end of last year, and the growth continues to be ahead of us. And Net Plus program continues to leverage the power of the R&E community to manage risk and maximize opportunity across a diverse set of cloud services. We've added recently some to support the community needs around data migration and management. We are beginning to undertake adding some cloud vendor risk management to the portfolio. And we've continued to invest in training for workforce development for both enterprise and research, and benchmarking of new cloud services through our CLASS program and our Cloud Scorecard program. Now, all these changes would not have happened without the great support of all of you in the community. I think literally thousands of community hours have been volunteered to help Internet 2 achieve these enhancements. Research computing and data professionals play a critical role in supporting research on campuses. And working with these research and computing and data professionals, RCD data professionals, allows Internet 2 to better understand and support the cyber infrastructure needs of researchers. We've just wrapped up our second year of an NSF Cyber Infrastructure Center of Excellence pilot. It's called the RCD Nexus, and it was funded by the Office of Advanced Cyber Infrastructure. And it looks to create a career center and tools and practices for professional development, for resources to support individuals and institutions. And it both leverages and augments the infrastructure that's provided by the Campus Research Computing Consortium, CARC. And we're very excited about continuing forward with that. And we're also really glad to be supporting the efforts to broaden participation in the R&E community with our partnership with the Minority Serving Cyber Consortium, the MSCC, and both Internet 2 and the MSCC are grateful for the support and funding made possible by the National Science Foundation. We had 2 awards, one in 2021 and one in 2022. The MSCC is supporting cyber infrastructure capabilities at historically Black colleges and universities, tribal colleges and universities, through shared cyber infrastructure resources, supporting for advancing the MSCC as a robust effort and collaboration led by minority serving institutions, and last, through a set of proof of concept grants to increase and accelerate cyber infrastructure enabled research and education capacities at the MSCC campuses by piloting a model for cyber infrastructure development at HBCUs, TCUs, and other minority serving institutions. As we move forward, we're excited about the continuing our work with the MSCC to broaden participation. And there's a first annual meeting of the MSCC later this week. So, you know, there's a lot I could add, but I really want to turn our attention to the future. Many of you know that we've started we actually have started last year our process to develop a 5-year roadmap, and we're going to have a session on Wednesday morning about this. So if you want to get an update on where we are, please join us for that session. So one thing I can say about the future is that it won't be boring. Of course, everybody's favorite topic these days is AI. We've already seen people talking about being AI first campuses and talking about move from the digital transformation to the AI transformation. And I was thinking back when I was starting out as an engineer, a colleague of mine and I were talking about how people could become very almost religious about their views on specific technologies. And he had a view when it came to technology that you should never love or hate anything that can't love or hate your back. And I was thinking this weekend, that may not age well. So certainly that's going to be an exciting topic in the future for all of us. Cybersecurity, the changing nature of work, the grand challenges that face us all, they're going to require even greater local, regional, national, and global collaboration. And empowering the R&E community with the infrastructure, capabilities, and services necessary to further those collaborations is going to be more important than ever. So I'm really proud to be part of this community and thankful for all of you and all your support. So look forward to, again, a great week. And with that, let me introduce welcome our program committee member, Dave Robinson from Grinnell College.
Hello, good morning. So my name is Dave Robinson, and I'm here today as a member of the 2023 Community Exchange Program Committee. And I'm delighted to have the opportunity to introduce today's keynote speaker. And hopefully I'll get the next slide. So, not that I need notes at all, of course. So Claire L. Evans is a writer and musician exploring ecology, technology, and culture. She is the singer of the Grammy-nominated pop group Yacht, co-founder of Vice's imprint for speculative fiction Terraform, and co-editor with Brian Merchant of the accompanying anthology Terraform, Watch Worlds Burn from MCD Books in 2022. I know what's coming, but I don't want to get it wrong. 2018 History of Women in Computing, Broadband, The Untold Story of the Women Who Made the Internet, is what she's here to talk with us today. And we really look forward to hearing her inspiring take on this, particularly as it pertains to our community. She lives in Los Angeles, where she's an advisor to students in the Media Design Practices program at Art Center College of Design. Please join me in welcoming Claire Evans to the stage.
Hi, everyone. Let me just boot up the system here. I figured this is the right audience for that. So this is me. I'm about 9 years old when this video was taken. My dad worked for Intel for 35 years, so I do not remember a time when I did not have a computer in my bedroom, and I loved the computer. I never felt like the computer was something that was like for boys or for girls any more than the TV or the washing machine was. I think I'm playing Myst in this video, which dates me, I guess. But yeah, some CD-ROM heads in the house. I was so excited about beating Myst that I made my dad film me. Nerd from the beginning. Anyway, I'm showing you this because, when I was growing up, again, I didn't think the computer was a gendered thing. It wasn't for boys, it wasn't for girls, it was just for me. It was like home. And when the web came along, I embraced that wholeheartedly, and it became my home too. I understood, like a lot of people of my generation, that the web was a place of connection and discovery and community and learning. But something happened in the time since this video was taken. I mean, obviously I grew up, but so did the internet, and it changed. It changed a lot. It stopped feeling like home to me. It stopped feeling fun a lot of the time. It stopped feeling safe. Not so much for me as a person, but really for me as a woman. And so a few years ago, I started to wonder, what happened? What happened to this place? So I looked to the past. I wanted to understand where this technology had come from, to understand where we were and where we were headed. I talked to a lot of older women about their experiences in the early computing industry and on the first waves of the web. And let me tell you, if you're looking to get the real skinny on something, get yourself a Rolodex full of older women. They have seen it all and they are ready to talk about it. And there's a lot to talk about, because the history of women in computing is the history of computing itself. That is to say, it's not a recent phenomenon. It goes way, way back, like way back. But we got to start somewhere. So how about we start in 1892? It should only take us about 7 hours to get through this all. For context, in January of that year, an immigration processing center called Ellis Island opened for business. In March, in Springfield, Massachusetts, oh, I missed that slide, the world's first game of basketball was played, invented by this guy who was a YMCA instructor and desperate to get a bunch of stir-crazy young people entertained indoors. Ooh, I'm just going to ditch the clicker. But it's not winter anymore. It's actually the 1st of May. Just shy of summer, just shy of the 20th century. And there's this funky little ad in the classified section of the New York Times that day. It says, "A computer wanted." And this is actually the first instance of the word computer in print. And okay, obviously it wasn't placed by a time traveler looking to buy a laptop in the late 1890s. Whoever placed this ad was looking to hire a computer, not to buy one. Because for close to 200 years, a computer wasn't a thing. It was a job, as in someone who computes, who performs computations for a living. And say you decided to answer that want ad. Well, first you take a math test, obviously. And if you passed, you'd be given a seat at a long table like this, and you would work at that table all day on complicated, large-scale math problems. You couldn't do it alone because the problems would be much too complex. So you would break those problems into little chunks and work on them collaboratively with a group of other people, crunching numbers and cross-referencing each other's work. And doing this with just pen and paper or maybe a rudimentary adding machine, you would advance astronomy or ballistics or maritime navigation or pure mathematics. You would essentially form the underlying computational infrastructure of the early scientific age. I mean, before there were computers to crunch these numbers, somebody had to do it, right? So these women, these bodies and minds, were the computational infrastructure, embodied. They would make science possible. Now, in terms of status, these were not necessarily glamorous jobs. Computing offices like those, they were thinking factories. The 19th century British mathematician Charles Babbage called what computers did mental labor. And that's a pretty good way to think about it. The prevailing idea was that human computing did not require intellectual talent or sophistication. It was just kind of work that you did with your brain, just like hammering a nail is work that you do with your arm. But it did add up to something, because human computers did a whole lot of stuff. They prepared ballistics trajectories for the US Army. They assisted in numerical studies of nuclear fission on the Manhattan Project. They crunched astronomical data at Harvard. They quite literally mapped the stars. And they cracked Nazi codes at Bletchley Park. The applications of human computing were diverse as the applications of any computing. These people tackled a lot of different problems. But they had one thing in common, and I think you've probably already guessed what that is. They were all women. In fact, computing was so much considered to be a woman's job that by the time computing machines came along, mathematicians would actually talk about and measure how long they took to process problems using terms like girl years or kilo girls. I know. And that might have been a novelty in the 19th century, but things change, and especially during wartime. The First and Second World Wars ushered thousands of women into the workplace, most famously, of course, as mechanics, but also as typists and clerks and telephone operators. In fact, telephone companies were the first major employers of a female workforce. In 1891, just shy of that New York Times classified ad in '92, 8,000 women worked for the phone companies. By 1946, nearly 250,000. And once again, just like in the computing offices, these were female bodies and minds forming the physical infrastructure of an emerging technological age. I mean, they're quite literally making connections by hand that are, of course, later made by machine. And by the early 20th century, this was common. Women were staffing switching boards, keeping records, taking dictation, filing documents, doing clerical labor that now are mostly performed by digital assistants, bots, automated systems, and of course, AI, many of whom still speak, by the default, with female voices. The human computers began to disappear around the mid-1940s, late 1940s, although in some domains, namely and most famously in aeronautics, important calculations continued to be done by hand well into the 1970s, which is when NASA dissolved the formal human computing divisions that were made famous by the book and later the film Hidden Figures. Now, something you might remember if you've read or seen Hidden Figures, and if you haven't, what are you doing? is that some of these former human computers actually found work programming the machines that replaced them. And these are machines that emerged from the spike in computer science research during the Second World War. The earliest electromechanical and electronic computers were developed in secret to crunch numbers for the war effort, primarily to trace ballistics trajectories for the boys at the front. And the first people who were hired to run those machines were the women who were already doing those same calculations by hand, the human computers. And because software was not yet seen as something more important than just patching cables like a telephone operator, or handling cards and paperwork like a secretary, or doing math like a computer, programming was a job that was given to women without much consideration, frankly. And these women accepted these jobs gladly, because finally they could contribute to the war effort, and here was something they could do with their mathematics education and aptitude that wasn't just teaching or becoming a secretary. Except, of course, that operating one of these machines was not a simple proposition at all. They had no precedent, right? They were the first of their kind. There were no instruction manuals, no how-to guides, no graduate programs. These computers were the very first. So when the mathematician Grace Hopper, herself no slouch, she was the 8th woman to get a PhD in mathematics from Yale, so not a dummy, when she was assigned to program the Mark I computer at Harvard in 1944, she had to completely reverse engineer the machine that she had been assigned to, studying wiring diagrams, taking components apart, sometimes sleeping under her desk, until she understood the workings of that machine as well as, if not better than, the hardware engineers who had built it without really thinking about users. The same was true for the 6 women who were assigned to program the first all-electronic programmable computer, the ENIAC, by the US Army. Now, when I talk about programming here, I'm not talking about banging away at a keyboard and like looking things up on GitHub. I'm talking about crawling around inside of a room-sized machine and doing stuff like replacing burned-out vacuum tubes and fixing shorted connections and manually patching in programs. You can kind of see that in this picture by hand. Serious work. And by the time they were finished doing all of that, the ENIAC could run differential calculus equations in seconds. It could run these ballistics trajectories faster than it would actually take the bullets to fly through the air. But the job of the ENIAC 6 was officially classified as being sub-professional, which meant they were paid less, of course. But maybe worse, when the ENIAC was finally announced to the press and to the public after the war, that is to say, the very first time people in the public were ever shown a computer or told what it was, these women, who were vital to its operation, were never introduced. So although the mathematical demonstrations the ENIAC ran for the press were prepared and programmed and set up by women, none of them were mentioned in the accompanying articles. In fact, in some of the photos, they're credited in the captions as models, or cropped out entirely by virtue of being unphotogenic. So, to right that historical wrong, I'm going to introduce them to you now. The ENIAC 6, everybody. Kathleen McNulty, Betty Jean Jennings, Elizabeth Snyder, Marilyn Westcott, Frances Belis, and Ruth Lichterman. And yeah, I know that moniker, ENIAC 6, has largely served to kind of obscure their individual contributions to the history of computing. I do think that ENIAC 6 would make a really good name for like an all-girl punk band. So someone please run with that, or tell your daughters to. Part of the reason that their job was sort of ignored is that nobody really understood what it was that they did. Because at the time, software was not a word. Neither was programmer. These women were referred to as operators or coders. No one really knew how to talk about it. One of the ENIAC 6, Betty Snyder, she tried to define the job, and she said it was something like a cross between an architect and a construction engineer. It's a pretty good description of programming now, I think. But the thing is that Betty's work and the work of her contemporaries at the time defined this role and gave it meaning. Programming, because of them and because of their efforts, became something that had its own value, something that was separate from just operating a machine. It became a language, became an art form, a way of ordering the world. And maybe you already know this history about the female programmers during the Second World War, but what most people don't know is that after the war, they didn't quit. Even as men were returning from the front and the expectation was that women would return to their domestic roles, Grace Hopper, Betty Snyder, and several of the ENIAC 6 they went on to careers in the early commercial computing industry. In fact, they headed the programming teams at the first commercial computer company in the United States, the Eckert-Mauchly Computer Corporation, which produced the UNIVAC computer. And the UNIVAC computer in the 50s was like synonymous for computer in the way that Kleenex is synonymous for tissues now. And they ran the software side of things. Why wouldn't they? They were the best programmers in the world. They were the only programmers in the world. They did the UNIVAC's logical design, they wrote the instruction set, and because software was not yet an off-the-shelf product, they actually created custom programs for every client. Insurance companies, aviation companies, government agencies, you name it. And they debugged all those programs on site whenever things went wrong, which was often. That was a ton of work. I mean, imagine programming and doing customer support at the same time. Yikes. But it was because they were overworked that women like Grace Hopper first started to actually push the art of programming forward. They were looking for ways to streamline and simplify the process so they could get some of their lives back. Now, during the war, they programmed at the machine level, quite literally. But after the war, they began to develop this idea of automatic programming, which is basically just the notion that programmers should be able to step above that machine level and start to think and code at a higher level of abstraction with the help of software intermediaries like compilers and assemblers and generators. They realized they needed to create software to help them write software, which is something that we're still actively trying to figure out. And that move towards systems-level thinking influenced the entire development of the industry and led to nothing less than the development of computing languages. Grace Hopper, of course, invented the compiler and spearheaded the effort to create one of the earliest and most important shared languages, COBOL, which is nobody's favorite, I know. But still, 220 billion lines of COBOL are still in use today, undergirding everything from government databases to ATM transactions. And the unprecedented longevity of this programming language, well, sure, it caused the software scare that we know as the Y2K crisis, and being associated with Y2K is probably a dubious reputation, but it goes to show how effectively these early programmers laid a long-term foundation for the development of modern computing. Their work is still with us today. And that's because Grace Hopper and her peers, they understood something really key, which is that computing could never develop as an industry, as a domain, if it remained something that was only the purview of experts, if it stayed in the hands of what was then considered to be like a shadowy priesthood of coders. Grace wanted to see programming made accessible to a new generation of people, people who weren't necessarily going to be conversant in the arcane process of flipping individual bits. And that could only be possible, she knew, if people could talk to computers in something like natural language, and if that language was hardware independent, so it could work as well on a UNIVAC machine as on an IBM machine, as on a Remington Rand machine. And these twin values of interoperability and access, regardless of expertise, they come up again and again in the history of women and computers. And they're just as relevant now as they ever were. In fact, in researching this history, I cannot tell you how many times I found myself reading about a technology or like an approach to technology that just, had it been implemented at the right time, at scale, might have led us to a completely different world today. So these women I'm telling you about, and that I'm gonna tell you about, they're not just like badass women from history, although obviously they are. But they still have a lot to teach us, because through their stories, we can actually pick up some useful tools, some tools that still work, tools that can help us to build things differently and better. So let's jump forward in time a few decades. By the late 1980s, Grace Hopper was a rear admiral in the US Navy. And a new generation of very different computing pioneers was on the scene. Here's one of them, looking something like an admiral herself, Stacy Horn. She looks really proud in this photo because she just founded an online community. And in those days, before the web, an online community usually meant a BBS system, a bulletin board system, which is, for the younger people in the audience, basically like a text window that you call on the phone and pay for by the hour. Stacy had been a user of a really popular BBS system on the West Coast called The Well. But she was a New Yorker. She still is. And because she lived in New York, calling The Well was a long-distance call, so it was expensive. And it was also a total culture clash. She felt way out of place with all these sort of Bay Area cyber hippie types. She was a real cynical New Yorker, and she did not want to hang out with the whole Earth crowd. So she founded her own BBS system, and when she did, she called it the East Coast Hangout, Echo. Now this ad gives you a sense of the tone of Echo. It's like snarky, funny, Gen X, New York. She hosted it not out of a garage in Palo Alto or in some big office funded by VC money, but out of her apartment in Greenwich Village, surrounded by figurines of Gumby and photos of her friends. She was a rare bird in many different ways, namely because in those days, women made up a very small percentage of the online community, maybe about 10%. We don't have good numbers for it. And the result of that, interestingly enough, was that using a female identity in early social spaces like BBS systems or listservs or multi-user domains, it would usually lead to, if not harassment, then just like undue attention. So a lot of early female internet users would use gender-neutral pronouns in order to avoid being bothered. And there's lots of interesting things about that. You know, people were able to play around with identity in ways that they can't anymore. That's a subject for a totally different talk. One of the results of that, though, was that it was genuinely hard for women to find one another online, right? Because you didn't really know who anybody was. Except for on Echo, on Stacy's community. Echo was about 40% female, which was staggeringly high for the time. It was one of the earliest online spaces to be truly hospitable to women in any way. Although Stacy always really resisted the idea that she created some kind of safe space. "Bite me," she wrote in 1998. "I wanted to get more women on Echo to make it better." She knew that she wasn't creating a refuge or making some accommodation to a vulnerable population. She understood that diversity is not a favor that you do to the underrepresented. It's an asset that serves the entire community. By making sure that she had lots of female users, she was creating a better product. She was making her whole system better. She knew that more women meant more perspectives, more conversation, and she was providing an online service whose success was predicated on providing compelling conversations for its users. So that translated to a better product. Of course, to be fair, she only had those female users because she was the only founder who was even remotely interested in courting women. She would do stuff that's kind of unimaginable now, like recruit people on the street from non-technical places like bars and art openings in New York City. Like Grace Hopper, she understood how important access was. She made access free for women for an entire year. And if a woman left her service, she would call her up on the phone and ask her what went wrong. She created private spaces in her community where women could talk to each other and report instances of harassment if necessary. She spoke to women's groups about the internet, and she taught Unix classes out of her apartment so that a lack of understanding and know-how would not be a limitation. Here she is teaching Charlie Rose how to use Echo. And all that was good, but really honestly, her main strategy was just baked into the design of the community itself. Because back in those days, online communities were moderated by hosts. We still have moderators today on communities like Reddit, but honestly, most moderation has been kind of outsourced to a sort of shadow world of traumatized contract workers who have no real relationship to the communities that they serve. But in those days, moderators were like the hosts of a party, people who got free access in exchange for making sure conversation was still active and genial. Every single conversation on Echo, of which there were hundreds, had two moderators, a man and a woman. That way, when women dialed in, some of them using online services for the very first time, they immediately saw themselves represented, not just in the culture of the place, but in the power structure of it too, which meant they were way more likely to jump in and get involved in the conversation. There were no lurkers on Echo. Echo still exists, by the way. This is basically what it looks like. It's one of the oldest continuously operating online communities in the world. Stacy never sold. She never packed it up. She never franchised. She never sold ads. She never even indulged in the fantasy of an IPO, even though so many of her Silicon Alley tech bubble sort of collaborators became millionaires for a lot less. She never even made the jump to the web. It's all still Unix-based. Because when Mosaic, the first web browser, came along, she couldn't afford to create an interface for it. And anyway, her service was a paying service, so why would she put it up online for free? She never got rich, and she never got famous. So why am I talking about her? Well, I think her accomplishment is massive. She achieved pretty close to gender parity on an almost completely male-dominated internet using horse sense and boots on the ground, community building. She cared enough to make it happen. And her platform has remained online, like through the rise and fall of empires, outliving so many other online things. And it has a small but devoted family of users because Stacy has cared enough to keep it going. And that is not a word that we hear very often, is it, when we talk about tech founders? Care. I think for a lot of folks in big tech, caring means something really specific. It means caring about. It means investing in a big idea and building it without the immediate promise of success, taking risks, being passionate. And of course, that's great stuff. But Stacy's legacy represents a kind of different form of care. Not just caring about, but caring after, taking care. Continuing that commitment of care beyond the excitement of the pitch and into the tedious long-term reality of something once it's been built. And that's something that our culture tends to associate with women. And in Silicon Valley, at least, professional realms associated with this kind of work, like content moderation, tend to be filled with people, often women, whose skills are not seen as being technical skills. But the way I see it, care is very much a technical skill. Because software is the mechanism by which people facilitate tasks for other people. And in order to do that well, effectively, you have to understand the task, you have to understand the mental model of the people approaching that task, where they're coming from, the social context in which they operate, and then you gotta translate all that messy human stuff into code. After that, you have to determine whether the tool that you're building solves a problem or just creates new problems. You have to go beyond metrics like growth and stickiness and market share and start really thinking about things like mental health, community, civic life, society at large. And social skills are essential in all of this. And by social skills, I do not mean just getting along with people. I mean being able to see a technological object or infrastructure as being enmeshed in a world of people. And yeah, it really helps if you care about those people. Now, I know that Echo can't realistically compete with its inheritors, but I come back to Stacy's story a lot because I think it represents this great lost opportunity. What if the architects of our present-day social platforms had made those same kinds of efforts at inclusion that Stacy had made? What if we were able to take that thinking even further and make sure that all marginalized identities felt safe online? What if those values, that approach, was central to the way that we built things, rather than kind of patched on after the fact, after people have been hurt? Would I be standing here talking about how the internet doesn't feel fun or safe or like home anymore? I'm not sure. And the thing is, Stacy is not an outlier at all. If you're looking for women in the history of computing, it really helps to look first in those places where people are cared for. Those places where form gives way to function, metrics give way to meaning, and capital gives way to community. Let me give you another example. This is Wendy Hall, Dame Wendy Hall, actually. She was given the female equivalent of a knighthood in 2009 for her contributions to computer science. But when this photo was taken, she was just a lecturer at the University of Southampton in the UK. Her field was pure mathematics, topology actually, not computer science, until she discovered this thing called hypertext. Now, today when we talk about hypertext, we're usually talking about the web. The web is written in HTML, as we know, or hypertext markup language, and it's interconnected by hypertext links. But hypertext is a much older discipline. It goes back to the 1960s, when computer memory was beginning to make accessible all new volumes of digitized data. And the question was, how do we turn that data into something meaningful, into knowledge? How do we make connections through it? And as computer memory increased and the amount of information that could be recalled grew and grew, those questions got more and more complicated, and in some corners of Silicon Valley became kind of a utopian cause, thinking about how everything could be connected to everything else. Wendy was turned on to hypertext through this fascinatingly weird, anachronistic thing called the Doomsday Project, which was a countrywide effort funded by the BBC to document British life, kind of like a digital time capsule. It was released in 1986 as a pair of video laserdiscs that you could navigate by pointing and clicking. And the discs had all this interesting multimedia material on them, like virtual walks through the British countryside and images of British cities, maps, and first-person accounts written by school children, all indexed and easily navigable. But what knocked Wendy out about it, it wasn't this material, which you could get in a library, but how it was navigated. So long before the web and games, like Myst, by the way, taught us how to point and click and move around digital spaces to access information following visual cues, this was really novel. I mean, Wendy had thought that computers were all like databases and compilers, Grace Hopper stuff. But this interface suddenly made all of that stuff feel really exciting. It made it feel comprehensible to people outside of computer science. And combined with the emerging technology of the personal computer, Wendy reasoned, and correctly, that it would make previously inaccessible knowledge accessible to untold numbers of people. And again, like Grace Hopper, like Stacey Horn, she was interested in opening up knowledge and computing knowledge to non-experts. And hypertext felt like the way to do that. In fact, it felt kind of revolutionary. Now, her colleagues at Southampton told her there was no future for her in her department and in computer science in general if she carried on with this hypertext, hypermedia stuff. It wasn't considered to be technical. But she ignored them, thankfully, and she dedicated her efforts to building a system that would make it possible to browse library materials through lots and lots of interconnected multimedia links and documents. She started with the archives at the University Library at Southampton, but by 1989, she was running a team that had built an entire system called Microcosm. And just as the World Wide Web would do a few years later, Microcosm demonstrated this new kind of intuitive way of navigating information. It made information dynamic and alive and adaptable to the user. In fact, it wasn't like the web at all. It was better. Now, you all know this, of course, but a quick primer here on the fundamentals. On the web, links are contextual, right? They're embedded in documents. So when the destination of a link is taken down, we get a 404 error. That link is rotten. And that piece of information about what connected two ideas together is lost forever. And that is a huge loss for our culture. That's metadata. That's essential stuff. Bad news. Microcosm, on the other hand, had a totally different approach. It kept all the links separate in a link database. And that link base communicated with documents as like an overlay rather than a structural change to the material, which effectively meant that there were no 404 errors, obviously, but it also meant that a link could have multiple destinations and multiple sources. It could go to different places. Different users could layer different links on top of the same material in order to accommodate different levels of fluency with the material. So, an undergraduate student would get something different than a graduate student, for example. It was built for learning. It was adaptable to people. And it valued that really important piece, which is the nature of the connections between things. And there were lots of hypertext systems in those days coming out of research labs and companies like Apple, IBM, Sun, Xerox, Symbolics. And nearly every major team building these systems had women in senior positions because hypertext was just kind of more open to people from different backgrounds. If you went to an early hypertext conference, you might meet poets, people in the humanities, historians. Wendy calls it the literati of computer science. And yeah, I know these don't look like much today, screenshot-wise, but all these early hypertext systems are so fascinating in their own ways and different. They did share one thing, though, which is that they placed the most value on the associations between ideas, why things were connected. To hypertext's small but dynamic community of scholars, that was the thing, the most important thing, because from why, you get the most interesting answers. In fact, it was so much the thing that when Sir Tim Berners-Lee, he got the male equivalent of a damehood for his contributions to computer science, when he presented his very first demo of the World Wide Web at the Hypertext 1991 conference in San Antonio, people thought his stuff was juvenile. Like, his paper wasn't even accepted. He had to fly himself out to San Antonio on his own dollar, well, probably his own euro. Well, that's too early for that. Anyway, it doesn't matter. Bringing his computer with him to demonstrate it on the conference floor. They took one look at this system and they were like, the links are contextual? They only go one direction? What good is a hypertext system if the links are going to break? He was a footnote. And interestingly, this is like my favorite anecdote about the entire history of computing, is that the time the demo session was held at Hypertext 1991, it coincided with cocktail hour. And because this is San Antonio, there was a margarita fountain in the courtyard. So true story, the very first time the World Wide Web was showed to anyone in the United States, everybody was outside drinking margaritas. And in fact, if you look at this photo, there's a margarita right there on the table. So this woman just like wandered in with half a drink and was like, no way. So unimpressed. Now, of course, we all know what happened with the web, right? 1 year later, in 1992, Tim Berners-Lee published the very first image to ever be clicked in a web browser. It was a photo of 4 women, actually. This doo-wop band called Les Horribles Cernettes. They were all female researchers at CERN, where he worked, who sang these satirical songs about life in the research lab. And this is totally unrelated to anything I'm talking about today, but I cannot not show you this video of Les Horribles Cernettes singing a song. They're in full ball gowns sitting on a supercomputer. I mean, come on.
I feel your screen with hearts and roses. I fill your mail file with lovely phrases. They all come back invalid user. You never let me into your computer.
The whole video is out there on YouTube. I beg you to go watch it. Anyway, yes. That's so cool. No one's ever clapped for that. You're the good nerds. OK. After that, obviously, comes everything else, right? The web became standard. By 1994, Tim Berners-Lee was giving the keynote at the Hypertext conference. And all those sophisticated hypertext systems, like Wendy Hall's microcosm, were a thing of the past. So there's no way for us to know, really, if something like microcosm, if something as sophisticated as this system could have replaced the web or been as meaningful for us today as the web is. Just like there's no way to know what social media would look like if something like Echo had had enough funding to transition to the web. But that doesn't stop me from dreaming about it. And that's really what I mean when I say that these women show us another way of building things. Their stories demonstrate just how many other paths have existed, have lain before us in the past, and just how many paths might still lie before us if we just look. It's important to remember that in technology, in history, in life, nothing happens in a vacuum. New technologies do not fall from the sky fully formed. They emerge along this longer continuum of ideas. Like programming languages, as we have them today, would not exist if not for the ingenuity of some overworked female programmers in the 50s. The web wouldn't exist if not for decades of research into hypertext ideas and protocols conducted largely by women. Social media, as we know it today, could not exist without decades of experimentation with online community building on the early internet, on platforms long gone, and some of which still persist. Tech history tends to be told to us as a story of solitary genius. Tim Berners-Lee, Bill Gates, Steve Jobs. And of course, those people are remarkable. They've all made their contributions, but they were never alone. They've always been surrounded by people and ideas. Because making big things requires big communities. That's what's so exciting about technology. But it's also what makes it hard to see where things come from. And perhaps more importantly, where they might go. Now, computers can still now perform in fractions of a second what would have taken a human computing office many, many girl years to complete. But let's not forget either that the computer as we know it today is named after the people it replaced. And it runs thanks to the people who stepped up. In the 1960s, women were half of the workforce in computing. And they earned 40% of computer science degrees at US universities until about 1984. So it can feel really surreal looking at an article like this one from Cosmo in 1967, in the late 60s, all about how computer science is an exciting new career path for young women. Grace Hopper is actually quoted in this article talking about how programming is a natural fit for women because it's just like planning a dinner party. And you have to just get all the steps ready, you know, one after the other. Like, is this from another dimension? It's kind of bizarre to see this now, right? A lot of technology historians suggest that the professionalization of the field led to a kind of implicit masculinization. Like, if it started out female, it had to be made male. And things like professional and educational requirements necessary to become a quote-unquote software engineer by around the 1970s made it more difficult for women to keep a toehold in the industry that they had essentially founded. And that this set a sort of male-dominated precedent that has only been reinforced over the years through misconception and through marketing images like these. This is an ad, the first ad actually for the Apple II in 1977. It makes it pretty clear who this stuff is supposed to be for, right? And in fact, if you look at vintage computer ads, especially from the 70s, you'll see two versions of this image. Either a woman watching from afar, wistfully chopping carrots, or a woman in go-go boots and a bikini swanning over a supercomputer or a server or something. How about this one? Products like these. The Honeywell kitchen computer, which, you know, took some know-how to learn how to program, but it came with a cutting board and an apron. And it condescended to its users in the ad copy. If only she can cook as well as Honeywell can compute. How dare you? I don't know. I'm a millennial, so I grew up with images like these. This is from Weird Science, which is a movie about some nebbish boys programming their dream girl. Now, no matter what form they take, no matter what media they're in, these images make us believe that men are somehow natural to the realm of computing, and women are, at best, accessories to it. I don't know what to call that other than like propaganda, because it's not true. It's a lie. It's not the way things are or have to be. And many of us in this room are proof. So, if you remember nothing else from this talk, like nothing about BBS communities or hypertext systems or automatic programming, please remember this, that if there is a boys' club that dominates tech, it's an anachronism. It's a historical fluke. And that anachronism can blind us to the fact that there is so much talent, so much richness of perspective, so much beautiful multiplicity out there, both in our history and in this room today. Which is why I'd like to end this talk by doing something that I never get to do, which is highlight those folks in this very room who I hope will someday be the subjects of future books and keynote talks because of their great contributions to technology. And that is the 7 recipients of the 2023 Community Exchange Internet 2 Inclusivity Scholarship. What? 7 remarkable women who are invested in building technology better. I'd love to see it. Yes, yes, yes. And if you're a previous year scholarship winner, stand up so we can celebrate you too. Sorry, is this embarrassing? We love it. Thank you so much. I'm so excited to see these people building a better future for us all.
My gosh, thank you, Claire. Wow. Woo, I'm like shaking, I'm so excited. What an honor to share the stage with all of you and you, Claire. Thank you, thank you. Hi, everyone. I am Meredith Lovelace. I'm the Senior Director of Digital Experience. Usually I do jazz hands with that. We are just so happy that you're here, and I want to thank Claire again for that inspiring talk. And really excited to move forward with the work that we're doing with the Internet 2 Inclusivity Initiative. Claire will be around the rest of today. She's going to get through her jet lag from California. So if you want to talk more or you have questions or want to find out where to buy her book, please talk to her. She would love to talk to you, as you can tell, very approachable. And also that walk-up music was actually Yacht. So you heard a little bit of her music today. I've been with Internet 2 for 10 years, and I have had the honor of getting to take pictures and do social media and get to know a lot of these Inclusivity Initiative award winners. There is a lunch today that you can learn more about it, and if you're double booked, triple booked, as most of us are, there's lots of ways to get involved. We'll tweet out links, there's things on our website. Please feel free to chat with our awardees and make them feel welcome. All of you first-time attendees, right? Yes, yes, yes. We will not make you get on the main stage ever again. Sorry, this might be a little scary. We also have a sponsor social hour tonight at 4:30 in the Augusta Ballroom, which is downstairs, 7th floor. So please do come, join us for a drink. Thank our sponsors for helping us, what do we say, hot lunch. The sponsors are the reason why we get hot lunch here, right? We really, really appreciate Mike Shepard and all of our sponsors that are here, really to make this a rich and robust conference for all of you. Enjoy your time here. We are thrilled to have you here. We are thrilled to all be together, and really appreciate all of you taking the time really to leave Zoom and come here. It really makes a difference for us to be together, to be part of that future that Claire talked us about. So thank you. Have a great day.